Welcome back. Today we are looking at the OSCARBIDE Indexable End MillR8 Shank3 cutting Diam review power and portability combined. The OSCARBIDE Indexable End Mill with our 8 shank, 3-inch cutting diameter, and 5 flute geometry is not just another CNC cutterit, is a practical demonstration of machining science in action. If you have ever wondered why industrial cutters behave differently under load, this tool is an excellent case study at its core. Machining is about controlled material failure. Check the video description for the updated price link. Instead of cutting in the everyday sense, the tool induces shear stress in the workpiece until the material plastically deforms and separates into chips. What makes this end mill special is how it optimizes that failure process through geometry, material science, and mechanical stability. With carbide inserts TPCN32PDTR TPG32, a rigid R8 shank, and a 5 flute configuration, this cutter is designed to balance 3 competing forces: cutting speed, heat dissipation, and vibration control. In a CNC router environment, especially in industrial settings, this balance determines surface finish quality, tool life, and dimensional accuracy. This review explains not just what the tool does, but why it works, using real machining principles that engineers and technicians rely on every day. The OSCARBIDE Indexable End Mill combines multiple engineering decisions that directly influence performance. Our 8 shank interface provides strong spindle-to-tool rigidity and minimizes runout under load. 3 cutting diameter enables wide surface machining with fewer passes, improving efficiency. 5 flute geometry balances chip, load distribution, and surface finish quality. 90 cutting angle ideal for flat surfacing and shoulder milling operations. Indexable carbide inserts replaceable cutting edges, reduce downtime and cost per cut. 6 overall length provides reach while maintaining structural stiffness. From a teaching perspective, each of these features solves a specific machining problem. For example, increasing flute count improves surface finish but reduces chip space. OSCARBIDE's 5 flute design is a compromise between aggressive material removal and chip evacuation efficiency. To understand why this end mill performs well, we must look at chip formation mechanics. When the tool engages material, each flute acts like a wedge. The carbide insert concentrates stress at the cutting edge, generating a shear plane in the workpiece. The sharper and more rigid the edge, the lower the cutting force required. Carbide inserts are significantly harder than high-speed steel HSS, which allows them to maintain a sharper edge at higher temperatures. This is critical because CNC cutting generates heat through friction and plastic deformation. If the tool softens, it dulls quickly and increases surface roughness. The 5 flute design increases the number of cutting events per revolution. This means, however, more flutes also mean less space for chip evacuation. That is why proper feed rate and spindle speed tuning are essential. In machining science terms, this tool performs best when chip load is carefully matched to material hardness and spindle torque. The R8 shank plays another crucial role. Tool deflection is a major cause of poor machining results. Even a small deviation at the spindle can amplify at the cutting edge due to leverage. A rigid R8 connection reduces harmonic vibration, keeping the tool path stable under load. The image above highlights the insert-based cutting system. In machining theory, this modular design is called indexability. Instead of sharpening the tool, you rotate or replace inserts. This ensures consistent cutting geometry across its life cycle, which is essential for precision manufacturing. In practical CNC environments, especially wood, MDF, plastics, and light aluminum, the OSCARBIDE End Mill demonstrates stable cutting behavior when properly tuned. From a vibration standpoint, the tool performs best at medium to high spindle speeds with moderate feed rates. This reduces the risk of harmonic resonance, which occurs when the tool's natural frequency aligns with cutting forces. Heat management is another critical factor. Carbide inserts allow the cutting edge to withstand higher temperatures, but chip evacuation must still be efficient. If chips are not cleared, they can recut into the material, increasing friction and reducing edge life. Surface finish quality is where this tool excels. The 5 flute configuration reduces scallop height between passes, creating smoother finishes that require less post-processing. This is particularly valuable in cabinetry mold making, and signage production. Check the link in the description to get yours today.